Lesson 5.3 Transformations and Symmetry of Polynomial Functions continues. In this video, we will be given graphs of two functions, write equations of one function in terms of the other. Analyze the graphs of f of x and g of x. Write an equation for g of x in terms of f of x. Alright, so in terms of helping you to see this a little better, I'm going to go and turn to Desmos, and from there we will look at what's going on. So on Desmos, I provided the same two graphs, but I laid them on top of each other on the same graph. So with the f of x function here, I can play with it a little bit to see what's going on. So here's my orange one, which is the g of x function. It lines right on top of the original function that you saw, which is your f of x. We want that to line up where the green g of x is. So the first thing I notice is that the graph is going up 2 units. So we know there's a vertical translation there, and we know vertical translations are added at the end. So now my function lines up on top of the original function. Now you're going to notice that the original point, one of the original points is up here at 2.8, and in the final one it's down here at 2.6. So the 2 value, the x value, didn't change. What has changed is the y value. Okay, so our y value is changing, so that means that it's our a that is negative. And that gives us our new function down here at 2.6. And so that's how we figured this out. So on this one here, they just ask us to write the equation. So all we're writing is that we have negative f of x, and then the graph went up 2, so plus 2. So this is not any different from the last chapter when we did this with quadratics. So what I'd like you to do is try this quartic function. Okay, again, they gave us points. We can see what's going on and we can try to match it. So go ahead and try it on your own, and then I'll walk you through it using Desmos again. Okay, so this time we have this here. So again, I put the two graphs on the same thing. We're going to notice that it goes to the right and it goes up, and then the points have changed a little bit. But my window here is not big enough, so whoops. Let's go ahead and adjust the window settings here. Y goes up to about 35. Okay, so here's our g of x. Okay, it lines up on top of the green one. We want it to end up over here. You'll notice that it moved to the right 3 units. So that means that we have -3 because we do the opposite in here. So move to the positive. But you'll notice that they're still not lined up. The other thing to notice is that the 216 became 532. Well, 2 plus 3 is 5. So that's the horizontal translation. The 16 becomes 32, the 1 becomes 2, the 0 doesn't change. So that means we're multiplying the y values by 2. And the minute we do that, our functions line up and we've received, we've gotten the formula that we're looking for, or the equation. So hopefully you also got 2f of x minus 3. And that's how you look at the graphs. What you're really doing is you're just looking at the points, right? And comparing what kind of change happened. So 5, where the other one was 1, 1, translated to 4, 2. So we look at each and see what's going on. Okay. At 0, if the number changes, that means you have a translation of some sort, either horizontal or vertical, right? And then if the other points change, that's when we know something else is applying as well, a multiplier of some sort. All right, hopefully that's enough for you to figure out 14 and 15 on your own. And go ahead and watch the next video to finish off your notes.